All right, let's try that again. We're working with acceleration. We've got a horse that's running at 4.0 meters per second in a westerly direction. She accelerates at, and I got a typo there, 3.5 meters per second squared. I fixed my units there as well. Meters per second squared in a westerly direction. So she's accelerating west for a total of 4 seconds. And we'd like to figure out what her final velocity is going to be after those 4 seconds. So the first step, and people talk about using GRASS or guess or grasp as some sort of a format for how you're going to answer a question. How many people have seen these things before? You know, there's these little memory aid acronyms. The idea is that we're going to write the givens first, okay? So I don't even need you to label it up as the givens. We're just going to understand that as mature high school students, we know to write the givens every single time, okay? So I want to write down these values. And as I go through, what's 4.0 meters per second? If she starts at 4.0 meters per second, in terms of variables like v1, v2, acceleration, delta t, what is that value? Yeah?
Her initial velocity, so v1.
Beautiful. Okay, so we can say it's v1 equals 4.0 meters per second. And now some people are going to say, should it be positive or negative? And this is where the next important part of your givens comes in. I should always have a diagram somewhere. It can be off to the side or it can be in the main body of my problem, but somewhere that's highly visible, I should have a diagram where I label this whole thing out. So I'm going to have my little horsey. Your diagram doesn't have to be terribly detailed. But I'm going to have my little horsey, and my little horsey is going to, my little pony, is going to go east. Or sorry, it's going to go west. I know this doesn't fit with the way a compass might look, never even shredded wheat, but we're looking at it from the other direction. And we're going to say west is positive. And my little pony is going to go towards the west. Just so that we can picture this scenario. And somehow it looks like my little pony got a little bit chubbier as the running went, but get the idea. We don't have to be artists here. This is like cave art physics. Yeah. Bulking up.
That just broke the rules.
Yeah, bulked. So she goes at 4.0 meters per second initially, and the way we've defined our reference frame here, she's starting from one position, getting to another position. So here's our 0 position, going in the positive direction. 4.0 meters per second is a positive value. Now, as we carry on with our little story, she accelerates at 3.5 meters per second squared west. What's the next given I've been given? Yeah?
What her acceleration is.
Okay, so we're going to write A equals 3.5 meters per second squared. And again, what, positive or negative? Positive. I know that I'm being maybe overly simplistic here, but I'm not trying to talk down to you. I just want to make sure that it all gets talked out. For 4.0 seconds, what's the next piece of information we know? Delta t. I like it. And it says, what's her velocity at the end of 4 seconds? Now, it gives the value 4 seconds again. That's not extra information. It's just sort of restating it. What's it asking for? What value is it looking for here? Yeah. Yeah, our final velocity. And so if we've called v1 her initial velocity, then we're going to call v2 her final velocity. So I'm just going to write v2 question mark. That's our unknown value. That's what we're working towards here. Another thing that you might want to make note of as we're looking at these, and we spent so much time talking about it, we might as well talk about it now because it's going to be useful in our final calculations. How many significant digits are present in our givens? Yeah, it looks like 2. It looks like the lowest number of significant digits is 2. Okay, I've got there, 2 sig digs. So I'm just going to make a little note of it to myself. My laptop seems to be a little bit jittery today. I'll have to restart it, but we'll get through this problem. Looks like we have 2 sig digs for this problem, so we'll just make a note of it off to the side. So we've noted it. What's a good formula for maybe trying to solve this problem? We've only learned a few formulae so far, so let's use it. I mean, I don't want to be a toolbox scientist, but we do have a specific tool that's going to help us solve this problem. What's the equation that's our tool in this case? Yeah? Yeah, the one A equals delta V over delta T, right? So some people say, all right, acceleration is equal to delta v over delta t. I don't see a delta v anywhere in my givens. What am I going to do? Yeah? No? Okay. If I don't see a delta v in my givens, oh, game over, can't do it, it's finished, right? Yeah.
Isn't it a variable?
Well, delta v is a variable.
No, but is it the variable? Because you can fill in, wait, no, I'm getting ahead of myself here.
No, you might be on the right track.
Do you substitute 3.5 meters per second squared for the acceleration and then 4.0 seconds?
Well, I could solve for delta v, you're right. I do have enough information to find delta v, but I'm not looking for delta v. I'm looking for v2. Do you think that delta v could be expanded out and written more complicatedly? Really, let's think about what the definition of delta v is. Delta v, by definition, is v2 minus v1, right? And I have v1, I want v2, so let's write delta v out in full. Oh no, you can say stuff like that. Don't feel stupid.
Yeah, but I was like, but there's no V2, but then I realized we just do it like algebraic.
Yeah. So we can expand out that delta v and actually write it out as sort of its component parts. We're not even going to think of it as a substitution. We're going to think of it as saying, hey, let's tell the whole truth about what delta v is, right? Change in velocity. What I'd like to do is get v2 all by itself. Now this is a little bit of equation balancing. What should I do? And I always like to rearrange the equation before I sub in values. Little kids and people that don't know better sub in the values first and then try to rearrange because somehow they think it's going to be easier. Let me tell you, as soon as this delta t ends up being 5026.753, it's way more work to start subbing in the values than it is, because I have to keep on writing out that god-awful long number every time. It's way more work to rearrange it with the numbers already subbed in than it is to just rearrange it with just variables. So I want to train you. I want you guys to get into the game with your head screwed on straight, and I want you to rearrange the variables before you sub in values. Subbing in values first, that's what little kids do. You guys are like, you're almost men, you're almost women now, okay? So I don't want to fall into that pit. What do I have to do to both sides here to get get rid of the delta t? Yeah, multiply by delta t. Let's do it. So multiplying by delta t, not a problem. Cancel, cancel. Acceleration times delta t equals v2 minus v1. But the game's not over yet, because the goal of this game is to get v2 all by itself. What do I have to do to both sides to get v2 all by itself? Yeah? Yeah, add v1. Okay, so I'm going to add v1 onto both sides. And again, that eliminates the v1 from this side. And really, let's think about this as a balancing act. Let's not talk about this old-fashioned terminology of taking things across the equal sign and switching signs. Let's really try and be balancers here, okay? So now we've got v2 equals v1 plus a times delta t. Beautiful, that's a nice little equation, and I can use that. Am I going to memorize this equation? Probably not. Why would I want to bother myself with memorizing ridiculous trivia? I don't want to memorize every frickin' permutation of every equation I've ever known. That's what computers and reference books are for. You want to have the basic fundamental skill of rearranging simple equations like this, and that's the way you should do it the whole way through the course. It's in your best interest. Yeah? Oh, sorry, it's a dot. It's multiplied by. Yeah. So v2 equals v1, if we want to write it in the preferred, equation on the right type of style, acceleration times delta t, and we can sub in our values. Go ahead, sub them in. But as you sub them in, here's what I want you to make sure you're doing. You are writing all the decimal places. You're writing all of the units, okay? I've run out of space on this page, but I'm going to sort of artificially make some more for myself. 4 times 3.5. Can anybody do it in their heads? 12 plus 2, 14? Yeah? Or 2 times 3.5 is 7, times 2 again is 14, however you do it in your head. The meters per second squared times seconds, though. Let's think about the units. What happens to that second squared, units-wise? Can you see that this second here and this second squared is going to cancel out the squared? So we're going to end up getting 7.0 plus 4 meters per second. So up here I say V2 equals positive 4.0 meters per second plus 4 times 3.5. It's going to end up being 14. 14 meters per second, 4 times 3.5, right? It's bed miss, so you have to do the multiplication stuff first. And 4 times 14, well that's, can anybody do it in their head quick?
4 plus 14.
What's that?
Can we add it?
What's plus?
You said 4 times 14.
4 plus 14, I'm so sorry. 4 plus 14, you're right.
That's
Is
18.
thank you, 18, that's a lot easier. Meters per second. 18 meters per second. Now somebody's going to look at this and say, Mr. Killens, shouldn't this be 14.0? I got 3.5 times 4.0. That's one step of this problem. 2 significant digits, right, is 14. And then when I go to add them, it's 14 plus 4.0, so no decimal places, because the 14 doesn't have any decimal places. Okay, so then we would have a therefore statement if we want to get the full marks. This is already rounded off to our 2 significant digits. Therefore, the horse has a final velocity of 18 meters per second. And you know what? I'm in a therefore statement mode now. So what should I have after my 18 meters per second?
Because
No?
I don't know if the percent of
West. It's positive, so we should give it direction. No, we're being kind of conversational here. 18 meters per second west. Okay, so we've got all of the critical things. I want to go back and make sure we know what all the critical things are, because these are the types of critical things that people sometimes mark for on quizzes. Wink, wink, nudge, nudge, know what I mean. Okay? We've got a reference frame, and you've defined your positives and your negatives. You write your givens with all of your variables and all of your units. Make a note of your significant digits. Write out your initial equation. You always want to write out your initial equation. You rearrange your equation or you isolate your equation without subbing in any numbers. So you're just using variables. That's a process thing. When you sub in your values, you sub them in with all the units. You get your final answer. You also have to have your final answer, if you need to do any rounding, rounded to the appropriate number of significant digits. Okay? And then finally, you have a therefore statement, and within your therefore statement, you have your numerical answer, and if necessary, associated direction. Okay? Now that's a lot of check marks. We count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Holy moly. Is a little question like this worth 10 marks? No, typically it's worth something like 5 marks. I'm looking for these things. And I wanted to make sure that you guys are aware that when I mark for a quiz, particularly the first few quizzes, I am really, really going to be eagle eyes looking for the details here, okay? So make sure that you're eagle eyes looking for the details too. Now later on as the course goes along, you're not going to be feeling like it's as much of a burden to sort of do this as much as it is at the beginning. As you go along, it's going to be natural. But it hasn't been a natural part of your life up to this point, so it doesn't feel as natural. The grade 12 kids, they say, oh, I can do this in my sleep. Putting in all the units, all these little communication things. It's a nice formal way to set it up so that anybody can follow it. Okay?